Hello everyone, this is Brother Mayo Codes, and I'm looking at a Cellular Automata water simulation that I created using Unity's dot system. So starting this project, I found this 2D liquid simulator, and this one uses game objects, but it tended to run fairly slow. It had a grid size of 80 by 40, which is around 1300 game objects, and once you filled up the map, it tended to drop below 40 FPS. So I wanted to take this and convert it over to Unity's dot system. So this is the final product. I'll give you a little preview on what it can do. So this is the same grid size of 80 by 40 as that other simulation, except using the dot system, I am maintaining around 230 to 280 FPS. So just like that simulation, you can draw whatever you want, fill it up with water, and you can erase blocks as well. And it also implements a pressure system so that the water will equalize. Through some testing, I have learned that the limits of this demo is basically around 130 by 130 grid size, which is around 17,000 entities. It basically maintains 50 to 60 FPS here. And no matter how much water, it still maintains that FPS. Getting into the code, we have the cell component. This is the only component in the system. It keeps track of whether this cell is empty or solid. It has some rendering data. It has data on the cell size, grid position, and world position. It keeps track of whether the liquid is settled based on if it has not been changed. The liquid value has not been changed in the last 10 updates. It will settle this tile. And then it keeps track of its neighbors' indexes so it can access them. And it keeps track of modify values. So when I calculate the physics update, it will store how much liquid is flowing out of this cell and how much should be going to my neighbor's cells. Next up is the liquid simulator job component system. This system handles all of the logic for the simulation. So every update I will get a list of all of the entities that contain the cell component. I will create two copies of that list. One is the current, which I will read from. It has all of the current entity data, and the next is one that I will write to with all of the future data after I calculate it. I have some values on maximum liquid, minimum liquid, compression, and flow rates. And the first thing I do is schedule this calculate water physics job. So if you look at this job, it is an iJob parallel 4, so it will be running on multiple threads. I validate this cell should be updated, that it's not solid, that it is not empty, and that it is not settled, and that there is enough water. I reset all of the modify values. I keep track of how much liquid is left in this cell. Then I attempt to flow to the bottom cell. So if I have a bottom neighbor and they are not a solid type, then I will determine my rate of flow, constrain the flow, and update the values, which means I will subtract the remaining liquid. I will increment modify self by how much flow, and I will add the flow to my modify bottom value. Then I'll make sure I still have enough liquid to continue flowing, otherwise I will set my liquid to empty and return. Then I will attempt to flow to the left cell following a similar formula. If I still have enough liquid, I will attempt to flow to the right cell, and if I still have enough liquid, I will attempt to flow to the top cell. And through all of this, I am keeping track of my modify values by adding the flow and subtracting the flow from my own modification. Lastly, I will update the cell changes in the next array. I will set a new cell component and change the certain categories that are important, such as the modify self and all of my modify values, and my sprite sheet frame, whether I have water or I don't. So once I have scheduled that job, I will complete the job. Then I will copy the current array from the future array, so now the current is a copy of that one. Next up, I will schedule my second job, which is apply water physics. So if we take a look at this job, what I do is I check to make sure it's not a solid cell. Then I will set my modified liquid equal to my current liquid, and I will check all of my neighbors and check their modify values. So my top neighbor, I will check their modify bottom and add it to my modify liquid, and same thing for left, right, and bottom. Next, I will check for the settle conditions. If my liquid has not changed at all, then I will increment my settle count, and once it reaches 10, I will settle. Otherwise, I will reset the settle count. Next, I have a flag for the renderer, and it will check if this cell's top neighbor has liquid in it, and if it does, it will not scale this tile so that it will look like the water is flowing down, and it will not render gaps between those cells. And lastly, I assign all of these new values. So after I schedule this job, I will complete it. I will update all of these entities based off of the future array. And I will clean up the memory and return. Next up is the renderer process. Now I'm going to leave a link in the description below for the video tutorial that I followed. And for you to understand that, you have to take a look at this sprite sheet that I have. So each of these tiles is 8 by 8. I have my empty tile here, my water tile, and my wall tile. Above it is empty space, and this is basically how I scale all of these tiles. Instead of using actual scale in Unity, which is kind of weird with ECS, I just shift the offset with the renderer upwards to make it look like it's scaled. So if we take a look at this code, you'll see I have my UV settings, and the main one you need to look at is this UV offset Y. So -1 is that bottom row of tiles, which means this will show the full size tile, and a value of 1 will show an empty cell. So basically here I will look for the flag is downflowing liquid, which is what we set up in the water system. If that's true, I will render the full tile. Otherwise, I will scale based off of how much liquid is in this cell. And that is my Cellular Automaton dots implementation. So I will have a link below to the GitHub page where you can download this and play with it yourself. Hopefully this helps out. I know there's not too much information right now on the ECS system, so hopefully this will help you get started. Thanks for watching.